Who is the best? If we look at this bar chart, everyone's eyes will probably go to the tallest bar and say, that bar must be the best. That bar must be the score for the best student or what have you. But if this particular bar is building on their neighbors, then you might argue that they're not as good as the bar over here, which is got sort of turkeys for partners. So one of these, though, is probably the best because each of them are what we call local maximum. If you look either to the left or the right of either one of these bars, they have lower bars. Every other bar in here either only has one bar adjacent, so the end bars could be counted, but we're not going to count them. We're not going to give them that. We're not going to give them that satisfaction. And every other bar is adjacent to at least one other bar taller than it. So we'd like to write a for loop that detects, we'd like to write code, and a for loop is going to help us, that detects these two local maximum. Well, these values are 3, 1, 4, 1, 5, 9, 2, and 6, and that's exactly what we have over here in our code. 3, 1, 4, 1, 5, 9, 2, and 6 on line 12 here. And then we have a Boolean, which is local peak, whose size is too smaller than the length of our input because we're going to not give the end values the chance to be a local maximum. We're going to not let our boundary condition allow that. You could make a test question that made it so that it was, add more conditionals and complexity to the problem. But for us, we're going to keep it simple and say we're just going to look at the inner elements, these right in here. And so those are the only candidates that could be a local peak, which means we're going to iterate starting at index 1, which corresponds to the value 1 here, and ending before we get to the length minus first element, which means we will be finishing up with element of value 2 here. And then we have an if statement inside the for loop. As I've told you countless times, a for loop with an if statement inside of it, that's pretty much the key to the APCS test and actually most of computer science. The conditional is often the fanciest, hardest part, and that's the case here. We have an and here, and so both sides of this and have to be true for this to pass. On the left-hand side, we're comparing the height of the bar to the left to the height of the current bar. And on the right-hand side of this double and, the height of the bar is compared to the height of the bar to the right. And if in both of those cases, our current altitude is higher, then we're going to set local peak to true. We choose I minus 1 as our index because I begins at 1, not 0. This will then set each element of local peak, and when we run, we see over here the result of running, we see false, true, false, false, true, false. So we have two trues, each of them just inside. And so those two truths recognize we are looking at these, so we have to look at the two truths just inside. This one's just inside from the left, this one's just inside from the right, amongst this center group. And so this indeed is the correct answer. And that is one of your more sophisticated uses of for loops and if statements that you might see asked of you on the APCS A test.